Imagine sitting in a quiet room, and suddenly, across the speakers, you hear a faint but sharp burst of sound that lasts only a millisecond. And then silence. That's essentially what astronomers experience when they detect fast radio bursts, enigmatic signals from the depths of the universe that arrive unexpectedly, last for only the blink of an eye, and then vanish without a trace. For years, these bursts were some of the biggest puzzles in astrophysics. And then something happened that changed the game. Scientists found one that didn't just appear once, but kept repeating. That source became famous. Its name is FRB 121102. Fast radio bursts, or FRBs, were first discovered in 2007 when a team of astronomers combed through data from the Parkes radio telescope in Australia. They noticed a single bright pulse of radio waves that lasted just a few milliseconds, but it carried as much energy as the sun emits in several days. It was unlike anything they had seen before. At first, many thought it might have been an error, interference from Earth, or even some instrument malfunction. But as more telescopes began looking for similar signals, more FRBs were found. They seemed to be real, and they were coming from space. For a while, every FRB astronomers caught was a one-time event. They would flash and then disappear forever. That made them almost impossible to study, because you couldn't point a telescope at the same spot and wait for more. Nothing else would ever show up. It was like trying to understand a firework you only see once in your life. And then, in 2012, something incredible happened. Using the Arecibo radio telescope in Puerto Rico, scientists detected a burst in the direction of a small, distant galaxy. And then, a few weeks later, it happened again. And again. This was FRB 121102, and it became the first known repeating fast radio burst. The fact that it repeated instantly ruled out some theories. If these bursts were caused by catastrophic events, like stars colliding, black holes swallowing stars, or supernova explosions, there would be no way for the same source to keep going. Those are one-time, destructive events. But FRB 121102 kept going off. To date, it has been recorded producing hundreds of bursts, and at times, astronomers have seen it flare up multiple times in a single hour. So what could be powerful enough to shoot out bursts of energy brighter than an entire galaxy, and do it again and again? One leading explanation is magnetars, exotic neutron stars with magnetic fields trillions of times stronger than Earth's. Magnetars are known to produce bursts of energy in the radio spectrum, and their extreme environments could explain the incredible power of FRBs. But even then, FRB 121102 is special. Its bursts sometimes come in clusters, almost like the source is firing off a machine gun of radio pulses. In 2016, scientists managed to narrow down its location to a dwarf galaxy about 3 billion light-years away. Imagine that for a second. This tiny source, somewhere in a small galaxy halfway across the universe, is strong enough for us to detect its bursts clearly here on Earth. That's like hearing the crack of a match being struck on the other side of the planet. And not only is the source far away, it seems to be located near a persistent radio source, possibly a nebula or even a small black hole. This combination only adds to the mystery. FRB 121102 has also shown another strange behavior. Its signals are highly polarized. That means the radio waves are twisted in a very specific way, as though they had passed through an intense magnetic field before reaching us. This tells astronomers that the environment around FRB 121102 is extreme, possibly near a massive black hole or inside the remnant of a powerful supernova. Whatever is happening out there, it's not an ordinary part of space. Over the years, new observations have added more detail, but also more confusion. Sometimes FRB 121102 goes quiet for weeks or months, and then suddenly wakes up and produces a storm of bursts. In one recorded event, scientists captured nearly 100 bursts in less than an hour. At other times, it seems to follow a loose pattern, with active and quiet phases, almost as if the source has a rhythm. But the exact cause remains unknown. The discovery of FRB 121102 changed the entire field of fast radio burst research. Before, many doubted that these signals were even real. Some thought they might just be unusual glitches in radio data, or maybe even interference from things like microwave ovens. But FRB 121102 proved beyond doubt that these signals come from deep space, and they can repeat. Since then, more repeaters have been discovered, but FRB 121102 remains the most active and best studied. What makes it so fascinating is that it's a natural laboratory. By observing its bursts, astronomers can learn about the plasma, the gas, and the magnetic fields it travels through on its way to us. Every burst carries information about the environment around the source and about the space between galaxies. It's almost like each flash is a postcard from the other side of the universe, telling us what conditions are like out there. And then there's the question that inevitably comes up whenever mysterious cosmic signals are involved. Could they be artificial? Could some advanced civilization be sending out radio pulses? Most scientists lean heavily toward natural explanations, especially magnetars. But the fact that FRB 121102 is repeating, structured, and extremely powerful has led some to speculate about the possibility. After all, radio is a common way humans send signals, so it's not unreasonable to imagine another civilization might use it too. Still, the bursts from FRB 121102 don't show patterns that look like language or information. They're more like explosions and messages. So the extraterrestrial hypothesis remains a long shot. What's certain is that FRB 121102 is forcing scientists to rethink what extreme astrophysical objects can do. Neutron stars, magnetars, black holes, and the environments around them may be capable of producing phenomena we still don't fully understand. And FRB 121102 isn't alone anymore. Telescopes like CHIME in Canada have found dozens of repeating FRBs, and the list keeps growing. Each new source adds another piece to the puzzle, but also reminds us how much we still don't know. Think about this: every time FRB 121102 fires off a burst, that energy has traveled for billions of years across space, untouched, until it lands on Earth and triggers a tiny spike in a telescope's data. We are catching signals that left their source before life even began to take hold on our planet. That's how vast the scales are when we talk about FRBs. And maybe that's why people are so fascinated. FRB 121102 is a cosmic mystery that combines mind-bending physics, extreme environments, and a touch of science fiction wonder. It reminds us that the universe is still full of surprises, and that even with our advanced technology, there are signals coming to us that we don't yet fully understand. As astronomers continue to track this repeating signal, they hope to uncover whether it really is powered by a magnetar, or if something even stranger is at work. Could it be near a black hole? Could it involve interactions we haven't discovered yet? Every new burst brings us closer to an answer, but for now, FRB 121102 remains one of the loudest mysteries in the cosmos. And here's the amazing part: this is just one source. The universe could be filled with thousands, maybe millions of similar objects, all sending out bursts of energy. We've only scratched the surface of what's out there. And maybe in the years ahead, we'll learn not just what FRB 121102 is, but what it means for the story of our universe.